Welcome back to my channel. Now that we have completed the initial assembly in part 1, it's time to power things up for the first time and verify that the most critical section of the radio, the DC power stage and the audio amplifier. Make sure your DC supply is set to plus 12 volts with the center pin positive and the outer sleeve as ground. Double check polarity before connecting. This is very important. Reversing polarity can damage components instantly. Also keep a multimeter and an external speaker with audio jack connector. I have prepared a small helper assembly using a DC jack DC socket and two alligator clips. This makes it very easy to measure the current drawn by the circuit. Before plugging in power, ensure that the radio is switched off. In this design, the power switch is integrated into the volume potentiometer. Turn it fully counterclockwise until you hear a soft click noise. That confirms the unit is off. Using this cable assembly, whenever I want to measure current, I simply connect my multimeter in series using these alligator clips. And once I am done testing, I can remove this setup and directly connect the power jack to the board. This simply saves the time and avoids repeated soldering and desoldering. As we have already connected the plug in the DC power jack, now let us turn on the power socket. Now slowly turn the volume knob clockwise to switch on the radio. At this moment, observe the current reading on your multimeter. It should be somewhere between 40 milliampere to 70 milliampere. Now let's test the audio stage. Insert a pair of simple telephone earbuds into the leftmost audio jack. As you slowly turn the volume knob, you will hear the noise flow rising and falling smoothly. Now in my case, I don't have any earbuds handy, so I'll try using a speaker. I can hear the noise floor increasing and decreasing as I rotate the volume knob, but it's quite faint and so it may not be clearly audible in recording. So let me connect an external Bluetooth speaker using an aux cable. Now you should be able to clearly hear the noise variation. This confirms everything is working exactly as expected. At this point, you have completed step 3. Now we are moving on to the most important and interesting part of the radio, the VFO or the variable frequency oscillator. Find the larger yellow toroid core. This is the T56 toroid. We will wind around 31 turns of enameled copper wire on it. First of all, cut about 2 feet of wire. Pass the toroid through the wire so it sits roughly in the middle. Start winding carefully. Each pass through the toroid counts as one turn. Keep the wire tight, evenly spaced and non-overlapping. The turns should sit close together but never overlap. Traditionally, radios use variable frequency oscillators for tuning because they offer excellent phase noise performance. Complete 31 turns. Make sure that the turns are evenly spaced, non-overlapping and tight. Complete the 31 turns, trim the ends to about half an inch. Then scrape off the enamel coating until shiny metal is visible on all sides. This ensures proper electrical contact during soldering. Now solder the two ends into the L1 position on the PCB. Now I am using my UVK6 receiver in CW mode at 80-meter band with a small loop antenna. You should be able to tune from about 4.059 MHz down to at least 3.9 MHz. Also, I'll check these 2 points. At 4.059 MHz, while adjusting the knob, you should hear a strong high-pitched tone. Ignore weaker tones, they are just harmonics. Now checking at 3.9 MHz, you should again hear the tone if the tuning is correct. If not, adjust the coil space or turns. Also observe that turning clockwise lowers the frequency. This is important. Make sure your circuit behaves this way. If the frequency is too low, remove a turn and retry. If frequency is too high, spread the turns and add turns. These are the two options you have. At this stage, you may notice some drift. This is normal because the toroid is not yet fixed and the surrounding soldering affects stability. Once satisfied, apply a few drops of super glue, then press the toroid gently onto the PCB and hold it for about a minute. This stabilizes the VFO. At this point, we have completed step 4. Now moving to next step, the crystal filter and the BFO. This step is straightforward. You have to insert and solder the 5 crystals provided. Do this one at a time. Insert, solder, and then trim the leads. Once you're done, move to the next. This ensures clean and accurate placement. This completes the step 5. Now moving to next step, we need to solder the Trifilar transformers. This is a delicate and important step. Do it when you are fully alert. A trifilar transformer has 3 windings, meaning 6 wire ends. You need to identify the twisted wires. You will see 3 wires twisted together and wound on a toroid. You have to carefully separate each wire end on both sides. The wires are already tinned, which helps soldering, and before that you need to do a continuity test to identify matching pairs. Ensure that the continuity in pairs like A to A, B to B and C to C. No continuity between different pairs. This will help us to identify whether there is any short circuit between the coils. You have to repeat this for all 3 transformers provided in the kit. Once you are done, we need to insert wires into PCB carefully. You can use tweezers if needed. Make sure correct pairing is maintained. Ensure that only the tinned part is soldered. If enamel is still present, it may look soldered but it won't conduct. Repeat the same for the second transformer. Insert wires into the PCB carefully. Make sure correct pairing is maintained. Avoid the enamel soldering mistake. Make sure you solder only on the tinned part. Complete soldering of all trifilar transformers. Once you are done, your board should start looking much more complete. This marks the completion of step 6. Next is the RF bandpass filters. We need to wind inductors L2 and L3. For that we need to cut 12 inches of wire for each toroid. Wind around 22 turns on smaller T36 toroid. You can follow the same procedure of winding that we discussed while winding L1 inductor. Maintain a tight winding. Keep turns tight and non-overlapping. They should nearly cover the toroid. Make sure you have wound around 22 turns. Now repeat the same method for the L3 inductor. Scrape off the enamel coating until shiny metal is visible on all sides. This ensures proper electrical contact during soldering. Repeat this for both the inductors. Now tin the leads of the inductor using a soldering iron and insert it in L2 and L3 positions into the PCB and carefully solder it. Trim the excess leads once you are done. Now your radio will look even closer to the completion. This marks the completion of step 7. Now next is installation of the BNC connector. We are almost done with the receiver section. Now install the BNC connector. This is straightforward. Insert it into the PCB, ensure pins are straight and solder firmly. Make sure that the RF pins are not bent away from the board. And that's it for part 2. In the next video, we'll complete the remaining steps and bring this radio fully to life. Thanks for watching. See you in part 3.